In this video, we will compute a line integral using Green's theorem. So we're computing the line integral of this vector field that we're given over a curve C, which we're told is the boundary of a triangle traversed counterclockwise. So let's try to draw the curve C. So it's the triangle with vertices 0, 0, 1, 0, and 1, 1. So it's this triangle, and we're going counterclockwise around it. So I'm going to draw it in blue. And we're going counterclockwise. Okay, so this is our curve C in blue. Now let's remember what Green's theorem says. It says that the line integral around the closed curve C, so remember it's important in Green's theorem that the curve be closed, meaning the start and end point of the curve are the same, of the vector field F and let's call the components of F, P, and Q. So the line integral of this vector field along the closed curve C is equal to, now in the picture I'm going to shade in the interior of the triangle green and call that two-dimensional region D. Now here's the statement of Green's theorem. This is equal to the double integral over the region D, which is the interior of the curve, of the function partial q partial x minus partial p partial y. Again, where p and q are the components of F, as I labeled them above. Okay, so let's compute what these are. Partial q partial x. Q is just sine of x. So the derivative is cosine of x. Minus, and partial p partial y. P is y cosine x plus 2y. So if we take the y derivative, let me put it in parentheses because there will be more than one term. The y derivative is cosine x plus 2. And something quite nice happens here, which makes the integral much easier. The cosine x just cancels out, and we're left with just minus 2. And we'll pull that constant out. And you should recognize this type of integral. We're integrating just the function 1, so that just computes the area of the region D. So this is just minus 2 times the area of the region D. And in this case, the region D is simple enough, it's just a triangle, that we can compute it without using calculus. The triangle has width 1 and height 1. And so we know that the area of a triangle is 1/2 times the width of the base times the height. So again, the area is 1/2 base times height. And in this case, the base and height are both 1. And so in the end, the area of the triangle is just 1/2. And so the value of this line integral is -1.